class, this is the fourth video of chapter number 9, force and laws of motion. In previous videos we have discussed about force, the two type of force, balanced and unbalanced force. After that we have discussed about inertia, which was measurement of mass, and there were three types of inertia. First was inertia of rest, inertia of motion, and inertia of direction. Okay, and after that we studied about Newton's first law of motion, which is also called law of inertia. Okay, law of inertia, we can also say that. Next thing we discuss about momentum. What was momentum? It was the product of mass and velocity. Symbol of momentum was P, and its formula m into v. Okay, initial momentum was mu, final momentum was mv. Okay, so these were the formulas we have discussed, and I told you about that mass can also change, but that mass is the change in mass is very less in our cases, so we can neglect it. Okay, let us say a car is driving for 10 kilometers or 15 kilometers, so there is some amount of petrol which will burn, so that means that mass get reduced. Okay, so that change in mass is very less, so we can ignore that. Now our next topic is Newton's second law of motion. What is the definition of Newton's second law? So it states that the rate of change of momentum is directly proportional to applied force. That's why we discuss momentum before second law. So if there is change in momentum means it can be either mass or velocity. Okay, so by applying force we can change both mass and velocity also. So if there is change in momentum, that means there must be some force. That means if we apply force, it will change its momentum. So how much momentum will change? We call it rate. That means if we apply more force, the momentum will change fastly, and if we apply less force, the change in momentum will be slow. Okay, so that's why we use rate of change of momentum. It is directly proportional to the applied force. This is the symbol for directly proportion. That means if first increase, then second also increase. If I say x is directly proportional to y, that means if x increase, then y increase, and if x decrease, then y decrease. You have studied it in also chapter number 4 of mathematics, that was linear equation in two variables. This works on this concept. Okay, all the linear equations are in direct proportion, and also we studied this in 8th class also. The name of chapter was direct and inverse proportion. Okay, so here what we have, that momentum change, force is directly proportional to change in momentum by time taken. Rate means divided by time, and change means final minus initial. For change we use this triangle sign. Okay, triangle means change. Okay, in chemistry you will learn that this triangle denoted that we are increasing temperature. So in physics we will use this triangle as change. So delta p by delta t, we studied it as delta p by delta t means change in momentum by change in time. That means for how much time we are changing the momentum, or for how much time we are applying the force. That is Newton's second law of motion. Force is directly proportional to change in momentum by time taken. I can say if we apply more force, momentum will change rapidly, and if we apply less force, if force is less, then change in momentum will be less rapid. Okay, let us find out the mathematical formula from this. What do you mean by change? Change means final value minus initial value. Okay, so final momentum minus initial momentum divided by time. What was the value for final momentum? mv minus mu divided by t. Can I take m as common? Yes, f is proportional to m v minus u by t. You know this formula, v minus u by t? It's the formula for acceleration. So I can say F is directly proportional to ma. This is the result of second law of motion. Do not confuse with these two formula. This is second law of motion. This formula is, this relation is second law of motion. This is the result we conclude from second law. Okay, this is not second law. of motion, this is second law of motion. Okay, now if there is a sign of proportionality, when we remove this sign of proportionality, we get a constant. F is equals to kma, where this k is constant. When we perform various experiments, we find the value of k is 1. So that's why we have the formula F is equals to ma. Okay, so this is the Newton's second law. Now let us discuss how we remove this sign, the proportionality, as k. Let us say we have two equations. One is x is equals to 2y. Second is x is equals to 3y. Okay, let us take it as 5y. Now I am making a box here. You have studied, you already have studied this concept in 8th class. This is just a revision. There are two boxes for, this box is for this equation, this is for this equation. Let us find out three values. If I put y as 1, if I replace y with 1, what will be the value of x? So 2 into 1, that is 2. If I replace this y as 2, it will become 4. And if I replace this as 3, it will become 6. 4, 8. If I replace this as 100, it will become 200. So can I say, as y is increasing, x is also increasing, or as x is increasing, y is increasing? So in first case, x is directly proportional to y. Okay, for second case, if I put y as 1, 2 and 10, x become 1, it will become 5, it will become 10, it will become 50. So in this case also, can I say x is proportional to y? So in both cases, x are proportional to y, but for first equation the constant is 2. For second equation the constant is 5. So for this equation we don't know what is the constant, so we put it as k, and when we perform some experiment we get the value of k as 1. So this is Newton's second law of motion, that is, when we apply a force, it will change its momentum, and the rate of change of momentum is directly proportional to the applied force.